problem and realized and determined that yes, they are inverses of each other, and it doesn't matter which way you multiply. If they are truly inverses of each other, it doesn't matter the way you multiply them, either A times B or B times A, you will get out the identity matrix. Now, sometimes it's very important for us to be able to find an inverse, not just determine that they are inverses of each other. And I'll show you why that's true by the end of this section. We'll show you why. But I'm going to show you right now how to find the inverse of a 2 by 2. It's pretty easy. The first thing we're going to look at is we're going to look at this thing called the determinant. Okay? And we find the determinant. So here's our 2 by 2 matrix. We find the determinant. The very first thing we do is we find the determinant, which happens to be, we take A times D, and we subtract B times C. So in other words, we kind of make a little cross here for timesing, right? A little X. And we take A times D, and then we minus B times C. That's called the determinant, right? If by chance the determinant equals 0, then A has no inverse. So if you find the determinant first and you say, oh, that equals 0, there is no inverse, because the way you find the inverse now, as you notice right here, you're going to take 1 over the determinant. So we take 1 over our determinant, and when that determinant is AD minus BC, then we're going to multiply it by what I call the mixed up matrix, M&M, mixed up matrix. So what we do is we take A and D and we switch places with A and D. So D goes up here and A goes down here, and then we just change the signs on B and C. I know there's not a whole lot of rhyme or reason here, but if you do that, if you take 1 over the determinant and you multiply it by this mixed up matrix, you'll come out with the inverse. This will give you the inverse matrix. Okay? So 1 over the determinant, and you find the determinant by taking A times D minus B times C. That's our determinant. Then we mix up our matrix by switching places with A and D, and then changing the signs for B and C. That's all we do. So let's take a look. Number 3 says, find the inverse and then verify that they truly are inverses of one another. So, to find the inverse, the first thing I'm going to do is I'm going to find the determinant. To find the determinant, I take 4 times 3 minus 5 times 2. Well, 4 times 3 is 12, minus 5 times 2 is 10. That's going to be a 2. Now I take 1 over the determinant, so I take 1 over 2, and I'm going to multiply it to my mixed up matrix. So I'm going to take 4 and 3 and switch places. Then I'm just going to change the signs on 5 and on 2. Notice they didn't switch places, I just changed their signs. And now I multiply 1/2 times 3, which is 3 halves. 1/2 times -5, -5 halves. 1/2 times -2, -1, and 1/2 of 4, which is 2. And that is its inverse. Now we need to verify it. Okay. So we're going to take our matrix A. So this equals A inverse. That's how we denote the inverse right there. A to the -1 inverse. So this is the inverse of A. Okay. So I'm going to take A, which is 4, 5, 2, 3. I'm going to multiply it by its inverse, which we said is 3 halves, -5 halves, -1, 2. I'm going to see what I get out. Now this is a 2 by 2. This is a 2 by 2. So I can multiply them together. This is going to be their new dimension, so it's going to be a 2 by 2 out here. To find row 1, column 1, I have to take row 1 times column 1. Okay? So I take 4, so row 1, column 1, it's going to be 4 times 3 over 2 plus, across the left, down with the right, 5 times -1. Well, this is like 4 over 1. 4 times 3 is 12, divided by 2 is 6. 5 times -1 is -5. 6 plus -5 is 1. That's a good start for our inverse. Remember, if they are truly inverses of each other, this has got to be the identity matrix. So now to find row 1, column 2, I take row 1 times column 2. So that's going to be 4 times -5 halves plus, across the left, down with the right, 5 times 2. So this is like over 1. 4 times negative 5 is negative 20. Over 2 is negative 10. 5 times 2 is 10. Negative 10 plus 10 is 0. Oh ho ho! That's row 1, column 2. That's what I wanted to see. Right there is a 0. Okay, now to find row 2, column 1, I have to take row 2 times column 1. So I'm going to take 2 times 3 halves plus, across the left, down with the right, 3 times negative 1. So this is like over 1, so that's going to give us just 1 times 3 is 1 plus negative 3 is 0. So row 2, column 1 is 0. Nice. Now to find row 2, column 2, I take row 2 times column 2, so I take 2 times negative 5 halves plus 3 times 2. This is like over 1, so that's going to be a 1, so negative 5 plus 6, negative 1. There it is. Oh, negative 1. Negative 5 plus 6 is not negative 1, it's positive 1. Hello! There it is. The inverse. This is the identity matrix, which means these truly are inverses of each other. That is the inverse. We found it. Woohoo! All right. So, when you want to find the inverse of a 2 by 2, the first thing you do is you find the determinant. Remember, to find the determinant, you take, if it's like this, A, B, C, D. To find the determinant, you take A times D minus B times C. Then to find the inverse, you take 1 over the determinant times our mixed up matrix. So we switch places with D and A. We then change the signs on B and C, multiply it together, and that is your inverse. If the determinant is 0, the matrix does not have an inverse. This is the second time that we've put this in a slide. It might be important. If the determinant is 0, then the matrix does not have an inverse. Okay? Now, what if we want to find the inverse of any n by n matrix? Well, we can do it, it's just a lot more difficult. Okay? When you do it, it's just a lot more difficult. So, the way we do it is we basically come up with our matrix here, whatever it is. We then we do this little dotted line, and we write the identity matrix right here. What we then do is we perform a lot of, we put it into basically, we change this left side into reduced row echelon form, just like we have in the previous section. Turning it into reduced row echelon form changes these numbers over here, and when this becomes the identity matrix, in other words, 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, but when it becomes identity matrix, this matrix over here is your inverse. And we're going to show you how to do that right now. Well, actually, you know what? I think I'm going to stop there. I'm going to show you this on another video, okay, just so it doesn't get too long. And you can look at it then. Okay, see ya. Bye.